This video is going to talk about function operations, and I have a box here with all of the operations that you need to know. They're pretty intuitive. Basically, if you want to take the sum of two functions, you're going to add them together. If you want to take you want to subtract two functions, you just subtract them, you multiply them. So I'm going to skip straight to the examples so that we kind of get used to what kinds of problems we'll see. Okay. So in this first example, I have two functions. I have f of x and I have g of x, and I want to find what f plus g of 2 is. So there are two ways I could do this. First, I could start with my function operation definition. So if I want f plus g of x, that's going to equal f of x plus g of x. In this case, f of x equals x squared, g of x equals x minus 7. So then if I want f plus g of 2, I'm basically just going to plug 2 into this new function. And so I will get -1 when I solve that out. The second way I can do it is very similar. If I want to find f plus g of 2, I first find f of 2, and then I find g of 2, and then I add them together. So f of 2 equals 4, because f is x squared, and then g of 2 equals -5, because g of x is x minus 7, and 2 minus 7 is -5, and so then I'll get -1 here again. Let's do one with division. So same functions, same f of x, same g of x. Now I want to find what f divided by g of 2 is. So I could first start with my function operation definition. So f divided by g of x is f of x divided by g of x. So that would be x squared over x minus 7. And in these cases, we have to remember that denominator cannot equal 0. So in this case, x cannot equal 7. And then I want to find f divided by g of 2. So I'm going to plug 2 in here. And I will get -4/5. The second way I could do it is just by skipping straight ahead. And I know I want to find f divided by g of 2, so that's f of 2 over g of 2. F of 2 is going to be 4. G of 2 is going to be -5. So I'm not going to do one with subtraction or multiplication, but it's basically the same as what we just did for those two examples. It just, you would have a different operation in there, but works the same way. A second type of problem that you might see with respect to function operations is one where you're not given an equation, you're just given a graph. So in these ones, I had equations. This one, I just give you the graph. And we still need to be able to solve things like find f times g of 3. So if I'm solving this one out, f times g of 3 is the same as f of 3 times g of 3. That's what our function operation tells us. So first I need to find f of 3. So if I want to find f of 3, I'm basically going to go see where on the red line, if I plug in 3 for x, what am I going to have for y at that point? So that's going to be a 1. F of 3 is 1, because this is the point 3, 1. For g of 3, I'm going to do the same thing. This one happens to be the same point. So if I plug in 3 for g, and I look for that point, the y-coordinate, or if I plug in 3 for x, the y-coordinate's going to be 1. So f times g of 3 would just be 1. Okay, let's look at our second problem here. When is f minus g of 2 greater than 2? So basically now I'm looking at the space between these two graphs. I want to know when the space between these two graphs is greater than 2. That's one way of thinking about it. So let's try out this point here. What if I had f minus 2 of 2? What would happen here? That would be f of 2 minus g of 2. Now f of 2 is going to be 0, because when x equals 2, our y-coordinate on that red line is 0. G of 2 is going to be 2. So our, because when x is 2, our y-coordinate on the blue line is also 2. So this is going to end up with a negative difference, which makes sense because that blue line is higher than the red line at x equals 2. So we want to think of the times when the red line is more than 2 units higher than the blue line. So we're basically looking at this section right here. If I did f minus g of 4, I mean, because that's where that purple section starts. This is at 4. I would get f of 4 minus g of 4. F of 4 is 2. G of 4 is 0. So I'm going to get 2. Great. And then if I kept moving up here, my difference would just get larger and larger. So any place where x is greater than 4 would be our answer. In this case, our functions stop at 5, so it actually would be x is between 4 greater, not greater than or equal to. X is greater than 4 or x is less than or equal to 5. If these had arrows and kept going, then you wouldn't need to specify that x is less than or equal to 5.